Q6167-2. A surface inversion can A. Indicate the chance of gusty winds. B. Produce poor visibility. C. Mean an unstable air mass. The correct answer is B. A surface inversion occurs when the temperature near the Earth's surface increases with decreasing altitude, in contrast to the typical decrease in temperature with increasing altitude. This phenomenon is often observed during calm, clear nights when radiative cooling causes the surface to lose heat rapidly. During the evening and nighttime, the Earth's surface cools down through radiative cooling, releasing heat into the atmosphere. As a result, the air near the surface becomes cooler and denser. In certain weather conditions, this cool air can become trapped beneath a layer of warmer air aloft, creating a stable atmospheric layer known as a surface inversion. When a surface inversion is present, it can have significant effects on visibility due to the potential formation of fog, haze, or low-level clouds. The inversion layer acts as a lid, preventing vertical mixing and the dispersal of moisture and pollutants. As a result, moisture in the air may condense into tiny water droplets or ice crystals, leading to the formation of fog or low-level clouds. These cloud formations can reduce visibility, making it challenging to see distant objects or landmarks. Fog is a type of low-lying cloud that forms when air near the surface becomes saturated, typically due to the cooling of moist air or the advection of moist air over a colder surface. Fog droplets are very small and can linger near the ground, severely limiting visibility. Haze refers to the presence of tiny suspended particles, such as dust, smoke, or pollutants, in the air. These particles can scatter and absorb light, reducing visibility and creating a hazy appearance. Both fog and haze can occur in the presence of a surface inversion because the stable conditions prevent vertical mixing and the dispersal of moisture or particles. As a result, poor visibility is often associated with surface inversions. In summary, a surface inversion can produce poor visibility due to the formation of fog, haze, or low-level clouds. The stable atmospheric conditions created by the inversion prevent the vertical mixing of air and the dispersion of moisture or particles, leading to reduced visibility and potentially hazardous conditions for transportation and outdoor activities. 6169. An aircraft is flying at a constant power setting and constant indicated altitude. If the outside air temperature, OAT, increases, true airspeed will A. Increase and true altitude will decrease. B. Increase and true altitude will increase. C. Decrease and true altitude will increase. The correct answer is B. True airspeed, TAS, refers to the actual speed of an aircraft through the air. It represents the aircraft's speed relative to the air mass surrounding it. True airspeed is affected by various factors, including air density, pressure, and temperature. As the OAT increases, it indicates that the air temperature is higher. Warmer air is less dense than colder air, leading to a decrease in air density. When air density decreases, it means there are fewer air molecules per unit of volume. This reduced air density has specific effects on an aircraft's performance. When the OAT increases and air density decreases, the aircraft will experience less resistance or drag as it moves through the air. This decrease in drag allows the aircraft to achieve a higher true airspeed for a given power setting. In other words, the aircraft will be able to fly faster through the less dense air. As the true airspeed increases, the true altitude of the aircraft will also increase. This relationship occurs because the indicated altitude is based on air pressure. As the aircraft gains speed and the air density decreases, the pressure acting on the aircraft's altimeter decreases. This can lead to a slight overestimation of the indicated altitude compared to the true altitude. In summary, when an aircraft is flying at a constant power setting and indicated altitude, an increase in outside air temperature, OAT, will result in an increase in true airspeed. This occurs due to the decrease in air density associated with higher temperatures. Additionally, The true altitude of the aircraft will increase as the indicated altitude may slightly overestimate the actual height above sea level. Therefore, the correct answer is increase in true airspeed and true altitude. 6170. An aircraft is flying at a constant power setting and constant indicated altitude. If the outside air temperature, OAT, decreases, true airspeed will A. Decrease, and true altitude will decrease. B. Increase, and true altitude will increase. C. Increase, and true altitude will decrease. The correct answer is A. True airspeed, TAS, represents the actual speed of an aircraft through the air, accounting for air density and pressure variations. True airspeed is influenced by factors such as temperature, pressure, and air density. When the OAT decreases, it indicates that the air temperature is lower. Colder air is denser than warmer air, leading to an increase in air density. An increase in air density affects an aircraft's performance in several ways. As the OAT decreases and air density increases, the aircraft will experience more resistance or drag as it moves through the denser air. This increased drag results in a decrease in true airspeed for a given power setting. In other words, the aircraft will fly slower through the denser air. As the true airspeed decreases, the true altitude of the aircraft will also decrease. The indicated altitude is based on air pressure, and as the aircraft slows down and air density increases, the pressure acting on the aircraft's altimeter increases. This can lead to a slight underestimation of the indicated altitude compared to the true altitude. In summary, when an aircraft is flying at a constant power setting and indicated altitude, a decrease in outside air temperature, OAT, will result in a decrease in true airspeed. This occurs due to the increase in air density associated with lower temperatures. Additionally, the true altitude of the aircraft will decrease as the indicated altitude may slightly underestimate the actual height above sea level. Therefore, the correct answer is decrease in true airspeed and true altitude. 6171. As density altitude increases, which will occur if a constant indicated airspeed is maintained in a no-wind condition. A. True airspeed increases, ground speed decreases. B. True airspeed decreases, ground speed decreases. C. True airspeed increases, ground speed increases. The correct answer is C. Density altitude is a measurement used in aviation to account for the effects of altitude and temperature on air density. It represents the altitude in the standard atmosphere where the air density is the same as the observed air density. As density altitude increases, it means the air density decreases. This can occur due to a combination of factors such as high elevation, high temperatures, and high humidity. When air density decreases, aircraft performance is affected in several ways. Maintaining a constant indicated airspeed means that the airspeed indicator in the aircraft is showing the same value. However, since the air density decreases with increasing density altitude, the true airspeed, TAS, will increase. True airspeed represents the actual speed of the aircraft through the air and is influenced by air density. As the true airspeed increases, the ground speed will also increase. Ground speed is the speed at which the aircraft is moving relative to the ground or the Earth's surface. It takes into account both the true airspeed and the effect of wind. In a no-wind condition, the increase in true airspeed will directly translate into an increase in ground speed. Since there is no wind to affect the aircraft's motion relative to the ground speed will be the same as the increased true airspeed. In summary, when density altitude increases while maintaining a constant indicated airspeed in a no-wind condition, the true airspeed will increase. As a result, the ground speed will also increase since there is no wind to affect the aircraft's motion relative to the ground. 6172. Density altitude may be determined by correcting A. True altitude for nonstandard temperature. B. Pressure altitude for nonstandard temperature. C. Indicated altitude for temperature variations. The correct answer is B. Pressure altitude is the altitude indicated when the aircraft altimeter is set to a standard atmospheric pressure setting of 29.92 inches of mercury in Hg or 1013.2 millibars MB. It is the vertical distance above the standard datum plane, which is a theoretical level where atmospheric pressure is 29.92 in Hg. However, in real-world conditions, temperature variations can cause deviations from the standard atmosphere. Non-standard temperature refers to temperatures that are different from the standard temperature for a given altitude. When the temperature is warmer or colder than the standard, it affects the air density and subsequently the aircraft's performance. To determine density altitude, pressure altitude needs to be corrected for non-standard temperature. This correction is achieved by comparing the actual temperature to the standard temperature corresponding to the pressure altitude. The temperature difference is used to calculate the density altitude. By making this correction, the density altitude accounts for the effects of temperature on air density. It provides a more accurate representation of the air density at a specific location and allows pilots to assess aircraft performance and make appropriate flight planning decisions. In summary, to determine density altitude, it is necessary to correct pressure altitude for non-standard temperature. This correction accounts for temperature variations from the standard atmosphere and ensures a more accurate representation of the air density.